Hello again, everyone. Question 5a from exercise 20a. Someone asked me to go through this. Usually I wouldn't quickly go through a problem which would be reasonably straightforward, I would have thought, but this one I thought I go through it because it's probably simple enough to explain, and also I think it is quite important that you know how to go through these show type questions, because usually in many cases you will be asked a question to show that one thing leads to another, or a result can be obtained from another expression, something similar to what's given in question 5a. Okay, so I think it is a very good quick example. So I'll go through it, and you should apply the similar methods when you're looking at other optimization or any other problems in the course. Okay, so this question 5a basically asks you to show that the second derivative of the function y, so you've got the function y equal to sine 2x plus 3. It says the second derivative of y plus 4y is equal to 0. That's what you need to show. Okay, so the first thing you can see here is there's a requirement for the second derivative of this function y. Okay, so the first thing you do is find the second derivative. Okay, so what we do now is we'll differentiate y twice, so we'll do it the first time. Now, just as an aside, just marking it off here, you know that to find the derivative, if you have y equal to sine f of x, okay, if you had something in that form, okay, you'd have dx equal to the derivative of f of x multiplied by cos space here. Okay, so that would be the derivative. Okay, in this case here it's quite important that you identify what f of x is, so that the explanation and working is quite clear. Okay, so what you could say is f of x is equal to 2x plus 3. It tells the person who's reading this that you've identified what f of x is, and you will differentiate something that would be in that form there. Okay, so we'll differentiate that first. So find the first derivative. F of x will be equal, using the power rule, equal to 2, and you end up with the derivative, first derivative of y is equal to, bringing this out the front, 2 cos, and having f of x in there. Okay, so you've got the first derivative. Now what we need is the second derivative there, so we'll differentiate this again. Now again, just for clarity, I'll put this out here. If you had a function y equal to cos, much smaller this time, hopefully I'll fit, f of x, okay, in this case dy dx would be equal to minus, okay, I'll just get this done, f of x, okay, and multiplied by derivative, still running out of space. Okay, so that would end up being that. F of x in this case is still 2x plus 3. We've already found the derivative of f of x, so we don't need to do it again. We just need to differentiate the cos function. Okay, so taking the derivative again of that, so the second derivative of y dx is equal to, now, okay, now you got a negative there. Okay, so it'll be negative, and you already have 2 from the previous derivative. Okay, and you multiply that again by f of x to give you 4. Okay, and the derivative of a cos function is sine, and you have 2x plus 3. Okay, so this, oops, sorry, I missed that there. Okay, the second derivative ends up being 4 sine 2x plus 3. Okay, so what can we see from that? If you have a look and compare this second derivative to the original function y, you can see sine 2x plus 3 appears in the second derivative. Okay, over there. Okay, so what happens is this here, this part is actually y. Okay, y is equal to sine 2x plus 3. So what can you do then? What you say is just my mouse is going crazy. Dx second derivative is equal to minus 4y. Okay, you end up with this. Now you can see we're getting closer to what we were looking for here. Okay, in fact that's what we have. Okay, and just bringing the 4 over to this side. So what I'd do is if I just to explain, if I'd subtract add 4y to this side, that would end up adding 4y to that side. So I haven't really changed anything. This side just ends up being 0. So I've added 4y to both sides plus 4y is equal to 0. And this is what was needed to be shown. Okay, you needed to show that function, the second derivative of that function, plus 4y is equal to 0. And that's what you've done. You've differentiated it once, you ended up with that, taken the derivative of that again, ended up with that function, and within that was embedded the original function y. Okay, and then you've shown what was needed. So that's pretty much it. It's very important that you go through this systematically and just think through the steps logically. Look at what's needed and do the pieces that's needed. So you look at that and you go, okay, I need the first derivative, I need the second derivative. So you go through and find those expressions, and you'll see that in many cases it will nicely fall out to what you're looking for. Okay, that's it.